Okay, this is section 6.3, literal equations. We're going to be talking about solving parts of equations, not always the same letter. Sometimes we'll solve for a different letter, or we'll be changing the order of an equation. That's why we use literal equations. So let's get a little review here. It says solve the equations for the unknown variable or for the designated variable if there's more than one. All right, let's look at the first one. So this one only has one variable, so I'm going to go ahead and circle that so we can focus on what we're trying to solve for. Thinking back to solving our equations from first semester, just draw a line down the equal sign. If we want to solve for a, that minus 3, we've got to get rid of that. So to get rid of that, we do the opposite. So add 3. And if I add 3 on the right, I have to add 3 on the left. 3's on the right cancel. And 5 plus 3 is 8. So a is 8. Looks a little funny to write the 8 first. I'm going to rewrite it as a equals 8. All right, first one down. Let's look at the second one. All right, in this equation, we have 3 variables. What? So what do we do here? Well, we only want to solve for one of them. We can't solve for all 3 at once. That's crazy. So let's go ahead and see what they want. They want us to solve for a. So I'm going to do the same thing I did before. And now I'm going to treat the b and the c as if they're just numbers. So don't worry about them being letters. It's okay. We still can get rid of anything we want by doing the opposite. So the a that we're trying to solve for is on the left side. There's a minus b next to it. So let's add b. Because I know adding b to a minus b will make it cancel. And that's what I want. So the b's cancel. And now I just bring the a straight down. And I have 2 letters. You can add them in any order you want. I'm going to go alphabetical, b, then c. And I don't know what b is, and I don't know what c is, but I do know the answer is just b plus c. So a is equal to b plus c. That's it. Let's look at number 3. Okay. This is an equation that says IR. What's that mean again? Well, IR means you're multiplying. It's like a little dot in between there. I times R is equal to V. And we want to solve for R. So I'm going to circle the R. Now remember, I said it was I times R. So how do we get rid of an I that's being multiplied? You got it. We divide. Divide by I. So if I divide by I divided by I is 1, or just canceled. And R is equal to V over I. Once again, we don't know what V and I are, so we can't combine them. It's just V divided by I. And that's it. Let's look at the next example. Remember, at any time, if I'm going too fast for you, you can always pause the video and get what you need before you start it up again. All right, let's look at this next one. A times x. Remember, A next to x means multiply. A times x plus c is equal to r. And we are solving for x. I'm going to circle the x. Okay. So this is like a 2-step from early in the year. We're going to draw the line down the equal sign. I want to get rid of an a and a c. The easier one to get rid of, though, is the c because it's being added. So much easier to get rid of an added number, or letter in this case. So we're going to subtract c. So c's cancel. Bring down our ax. And r minus c is just r minus c. That's it. Now, if you're still not quite sure, let's circle that x again, because we're still trying to get rid of anything that isn't x. So to get rid of the a, which was being multiplied, we're going to divide. And we have to divide the entire side by a. You can do one at a time if you want to, but I'm just going to do it all at once. A's cancel. And our final answer is x is equal to r subtract c all over a. And that's it. So we're basically shifting letters around so we can solve for a different variable than the one that's presented. And that's all we did on number 4. Let's look at number 5. All right. This is just W is equal to A divided by L. Remember, a fraction bar means division. And what are we trying to solve for? We're solving for A. So I'm going to circle the A. Now remember, we said we're dividing by L. If that's what we want to get rid of, then all we have to do is multiply by L. If I multiply by L over here, I will complete the plan. So if I have a divided L and I multiply by L, they cancel each other out because L divided by L will be 1. So I have on that side just A. On the left side, I have W times L. So my final answer, I like to have the A first. A is equal to W times L. You could even take out the dot if you wanted to, just WL. That's it. Do you recognize that equation at all? A is equal to W times L. If you think about it for a minute, if I draw a rectangle and call this the length and this the width, the area would be length times width or width times length. That's it. That was actually an area equation. Very nice. Last one. We've got 1/2 Z, or 1/2 times Z, I'll sneak in a dot, is equal to P. And we want to solve for Z. All right. So to get rid of the 1/2, we want to multiply by the reciprocal. So if we multiply by 2/1 on both sides, we'll get rid of the 2's and the 1's because everything cancels. 2 divided by 2 and 1 divided by 1. Just going to be 1. And draw my line down the equal sign. So Z is equal to, what's on the other side? Well, 2/1 is just 2. So that's just 2P, or 2 times P. And that's it. All right, so this is all good if you're trying to change an equation into a different form. But if you have no interest in changing an equation to a different form, then this really isn't necessary. Let's talk about when we do want to use this for sure. And some of those will be helpful. You'll see them when we get a good example. But let me show you an example we've been working on. Now, if you remember from last semester, we learned the 3 equations of lines. Standard form is the last one we covered, and that was just A times X plus B times Y is equal to, I already messed up, is equal to C. All right, that's one equation. Then we learned before that point slope form, and that was Y minus Y1 is equal to M times X minus X1. And that's what that was, point slope form. So let's look at the last form, which was actually the first form we learned, which was slope intercept form. If you recall, this one had a slope, which was M, and a y-intercept, which was B, in the form of y equals mx plus b. So now let me ask you a question. If you had a choice of which one of these you prefer, which one would it be? Would it be standard form? Would it be point slope form, slope intercept form, or, yes, I will give you an option, none of the above? I get it. But if I had my choice, I actually prefer point slope form. So if I have something written in one of the other 2 forms, I want to change it into point slope form. Or maybe you like slope intercept form, because all you need is an M and the y-intercept, and you plug them in and you're done. And you don't like standard form, so you want to change it into slope intercept form. So that's what we're going to use literal equations for, is to change from one form to another. Not because you're told to, but because you want to. So let's see what happens here as we try this out. So let's say you like slope intercept form, whether you do or not. So we're going to go ahead and write that down to remind ourselves the goal. And let's look at this point slope form, which is the one I prefer, actually. So if I have, this is what I want, and this is what I have, there's not much difference here. I see a y. It's in the same location as that one, so I like that. I don't have a minus 10 on this side. Probably want to get rid of that. I don't have any parentheses, so I probably want to get rid of those. So let's see where this goes. I'll bet we can do this. So I'm going to draw my line down the equal sign. My goal is to get it to look like this, so that means it's going to be y equals. Right now it's y minus 10. Well, to get rid of the minus 10, I know I could add 10, but before I even do that, I did mention the parentheses. Let's do this. Stay with me for a second. If we want to get rid of the parentheses, couldn't we just distribute the 3? That'd be a lot nicer. So what is 3 times x? Well, that's just 3x. And 3 times 2, 3 times 2 is 6, so just add 6. Now let's go back to our plan. I want to get rid of that minus 10, so I'm going to add 10. All right. Notice I can't add the 10 to the 3x because x is something we don't know. You can only add a number to a number, and that's a 3x. That's actually a letter. So the 10s on the left cancel. The y drops straight down, and we still have 3x plus 16. Hey, I think we're done because all we wanted was to change it into slope-intercept form, where my slope, my m, is 3, and my b, or my y-intercept, is 16. Nice. Let's see what happens on the second one. All right, looks like about the same approach. Let's get our goal. Y equals mx plus b. Awesome. So again, I think the best thing to do would be to get rid of the parentheses. Let's distribute that -5 first. So we'll keep the y plus 7 in play here. -5 times x is -5x. Negative times a negative is a positive, so that's now a plus 15. There we go. Now, if I want to get rid of that 7, because I want it to be just y, it's going to be subtracting 7. I have to subtract it from the 15, because that's the number on the right. 7's cancel, and we have y is equal to -5x. Let's see, 15 minus 7 is just 8. And that is my slope-intercept form that I was looking for. All right, let's look at number 3. So number 3 is in standard form. We want to change that into y equals mx plus b. Well, if I want y by itself, maybe we can kind of focus it this way. If I want y by itself, that's the only thing that's on the left side if you want y equals mx plus b. Then I got to get rid of a 4 and an x and a 3. What would be easiest to get rid of first? Well, if you remember what we learned before, let's get my line down the equal signs. Let's see the two sides. It'd be a lot easier to get rid of something that's being added. I know it's in front, but it's 4x plus that. I could get rid of that first. Let's do that. Subtract 4x. And remember, I want the x first. So see what you think about this. I'm going to do minus 4x, but that will not combine with the 12. I'm just going to write the 12 second because I want the x first. You'll see in a minute. So the 4x's cancel on the left. All we have left is 3y. And I'm going to put that -4x, and that was a positive 12. So that's it. So there we're close. We're close. We got to get rid of the 3 now. How do we get rid of the 3? Well, to get rid of the 3, if it's being multiplied, and it is, we're going to divide by 3. But remember how I said divide everything by 3? It'd probably be easier since we're trying to write this in separate terms, like 1, 2, 3 terms. I'm going to divide each one by 3. I know before I put the number underneath the entire side, but I'm going to show you how this is going to work pretty well. So 3 divided by 3 is 1, so don't have to worry about that, just y equals. -4 over 3 would be a decimal. I'm not going decimals. Just write down -4 over 3. -4 over 3x. Then what is 12 divided by 3? Well, 12 divided by 3 is 4, and we're done. So it's kind of nice if you do have numbers involved that you take care of each one at a time instead of all at once. We certainly could have put 3 underneath -4x plus 12, but it would not have looked as nice as this, where you can still see your slope is -4/3, and your y-intercept b is 4. I'll get get this eventually. B is 4. There we go. All right, interesting. Let's try number 4. Another one just like that. Let's go with y equals mx plus b. Okay, so my goal again is to get y by itself. And we learned last time the best way to do that is get rid of the x because it's being added. I know it has a negative sign next to 5, but that's just being added. So we're going to add. Wow, that was terrible. We're going to, it's being added, so we're subtract a negative, but it's a negative, so we were right to add a 5x. So we're going to add 5x because you want the 5x and the negative 5x to cancel, and it will. Add 5x over here. The 5x's cancel, and all we have left is 2y is equal to. Now remember, I want the x first, so I can't combine them. I'm going to put 5x plus 10. Now the last step, I just have to get rid of the 2. So I'm going to divide everything individually by 2 in hopes that this gets nicer. So 2 divided by 2 is 1, so just y equals. Well, 5 divided by 2 is a decimal. I'm not doing that. 5 divided by 2 is 5 over 2. X, keep the x. And 10 divided by 2 is 5, and we're done. So I know that my slope is 5/2, and my y-intercept is 5. My b is 5. That's it. Last couple. Here we go. All right. So maybe you don't like my method. I like the slope-intercept point slope form. We'll get it eventually. You want y equals mx plus b. That's fine. I can do that. All right, so all we have to do here, as we learned before, we saw this earlier in our examples, is we want to get y by itself. Well, the only thing that needs to go is the 8, but we don't want to deal with the parentheses either. So let's just distribute the negative 1/2 first. Keep the y plus 8. Negative 1/2 times x is exactly negative 1/2 x. Negative 1/2 times negative 10, that's a positive 2 negatives. And half times 10, or 1/2 of 10, is 5. Now all we have to do is subtract 8 to get rid of the 8, and we'll be done. So it'd be y, 8's cancel, is equal to negative 1/2 x, and 5 subtract 8 would be a negative, and that's negative 3. And once again, just as long as we're staying with the plan here, our slope is negative 1/2, and our y-intercept, or b, is negative 3. All right, last one. Same approach, except, oh, not same approach, what am I saying? This is actually going to be standard form. And a lot of people don't care for standard form, so we change it into y equals mx plus b. So the only thing you have to do here is get the y isolated, y by itself, because you want y equals mx plus b. So what should I do first? Well, as we know, the best thing to do is get rid of the 7x, because it's the one that's added or subtracted. In this case, it's subtracted. It says minus. And that's going to be adding 7x to get rid of it. Wow, bad example. Try that again. The 7x is going to be subtracted to get rid of it. That's a positive 7x. So we want to subtract 7x. So I'm going to subtract 7x on the right. And if I subtract 7x on the right, that will give me, I like to do the x first, right? So it'd be negative 7x plus 9. And on the left side, the 7x's have already canceled. And all we have left is a negative 3y. Now, how do I get rid of the negative 3? Well, that negative 3 is being multiplied. So I'm going to divide. And again, I'm going to try to divide each term by negative 3 so I can do it individually. Negative 3 divided by negative 3 cancels. They're the same. That'd be 1. So it'd just be y. Now, a negative divided by a negative is a positive. So this can be a positive. But 7 divided by 3 is a decimal. I don't want that. So I'm just going to knock out the negatives. Call it 7/3 x. Then I've got 9 on top, negative 3 on the bottom. 9 divided by negative 3 is negative 3, so it's minus 3. and that is my equation. I know my slope is 7/3, and I know my y-intercept is -3. All right, so that's how we use literal equations. They're used to change one formula into a different form. If you don't want to solve for the given variable, you can change it around. It does come in handy sometimes when we're trying to solve an equation or work out a problem. And as you saw in the last examples, you can turn any problem into any one of the three forms. If you're trying to write the equation of the line and you prefer standard form, or heaven forbid they tell you have to write it in standard form, you can change it into standard form. If you prefer point slope form, you can change it to that. And if you prefer slope intercept form, you can change it to that. So it's a method of solve. They're all solved the same. There's the same equation of the same line, but there are three different ways to write that equation, and you can decide which one you want to use. All right, that should do it for now. If you have any questions, talk with your teacher, and they will answer any questions you have. Have a good one.